So very good afternoon one and all. Am I audible? So welcome to day 5 afternoon session on Smart Traffic Junctions using IoT. So I warmly welcome all the participants to the 1-week National Level Online STTP Programme being organized by Department of ECE, Narasaraopet Engineering College. Okay, can we start? Am I audible? So today in this session I would like to talk about how to create a smart traffic junctions. So wherein I will be talking about how the vehicle gets communicated to the traffic signals. So far there is no connectivity in between the vehicle and traffic junctions, right? But when you have smart city scenario, then obviously there will be a connectivity between the vehicle and the smart traffic junction. For example, say if you have a smart ambulance, so which is going on a road towards a traffic junction, so the smart ambulance will be connected with smart traffic junction. So before it gets into the traffic junction, it will be sending data in which way it has to go, and thereby the green signal will be applied in such a way that there will be no stop signal for ambulance which is going through that route. So which means that there is a connectivity between the traffic signal post and the vehicles there. So in the similar way, I wanted to create a density, so I wanted to identify where the density is high. So in that way I would like to have the green signal. In the remaining ways I should have a red signal. So in such a way that I need to create a smart traffic junctions by using IoT. So we have to understand how to create a connectivity between the vehicles and the traffic signal post there. So in this session I would like to show you some demonstrations between the traffic signal post and the vehicles and the vehicle to vehicle also. So I will be showing you quick examples on how a vehicle will be communicated with another vehicle. So which is like intervehicular communication. So intervehicular communication is also very important in the traffic signal post, and also vehicle to traffic signal post is also very important in order to identify the density of the number of vehicles there. So that is also a quick important scenario, so where we have to look at, right? And also when you have multiple number of vehicles here and there across the traffic signal post, so we cannot rely on one communication technology, right? So you should have a group of heterogeneous wireless networks deployed everywhere across the traffic signal post. So we have to identify. So this identification can be done in two ways. By using CCTV surveillance, we can identify how many vehicles are there. So using that feed, we can able to understand how much is the density there. And also in the second way is that by using simple IoT protocols, we can easily identify how many number of vehicles are there, which is like mass counting of vehicles can be done very easily when you have IoT, which is like smart vehicles and also the traffic signal here. Okay, so let us quickly talk about this and we'll do hands-on on this. So am I audible? Okay, so let's talk about intervehicular communication first. So in this short session of 1.5 hours, I would like to demonstrate two cases. One is intervehicular communication, second is like vehicle to traffic signal post communication. So I would like to focus on two important things: intervehicular communication and also vehicle to traffic junction, so that we can easily identify how many number of vehicles are there across the traffic signal post. Okay. So let us jump into intervehicular communication. If you want to make an intervehicular communication, so this is very important because today, so if the vehicle is before you, you will be applying horn in order to ask the vehicle to go aside, right? So generally sound pollution is also an important scenario in the traffic junctions. So unwantedly people hit siren, so it creates a sound pollution. in the traffic signal post. So when you have inter-vehicular communication, so no need to apply horn, because the vehicle itself can understand that there is a vehicle behind it. So it gives a notification to the driver saying that there is a vehicle which is very nearer. Either you have to drive fast, or you have to give space for the the vehicle which is behind. So like that you need to create some communication between the driver and the vehicle, and also you need to create a communication between the vehicle and vehicle. So let us understand how to create a scenario of vehicle to vehicle communication, and then we'll be talking about how to create a communication between vehicle and driver. So let's talk about it. So let me open the Google Colab. So let me write some points. Okay, so I guess I have not shared this Google Drive, Google Colab, right? So let me share that also. Okay, so what I wanted to demonstrate is inter-vehicular communication, and also I wanted to have something like vehicle to traffic signal communication. Okay, so I wanted to understand how many vehicles are there in one route, thereby I can able to calculate the traffic density. So that is one point. And intervehicular communication, generally one vehicle will be communicated with another vehicle. Say if something is happening inside one vehicle, say there is a malicious case which is happening in one vehicle, so then immediately, so these days what central government is saying that in every vehicle, in every public vehicle, they have to install a GPS tracking system, and also they have to install one emergency button. If something is happened in that vehicle, they can press that emergency button immediately, so the notification will be sent to the police, and the police will be tracking that vehicle. So this is a GO which is passed by the central government, but here and there, so there were only few public vehicles where they are having GPS tracking system along with emergency buttons. But if you have a smart city scenario, so every public vehicle, it can be auto, or it can be a private cab, so you will be having an emergency button. So when you have that emergency button, so you can press that emergency button, so then immediately your GPS, the vehicle GPS link will be sent to the police, and the police will be taking care of where the vehicle was going, what was the movements and all, and they can easily stop that vehicle, or they can easily track that vehicle there. So and also, why not we have a vehicle intervehicular communication there? Say if you press an emergency button, so that will be sending it to the police, right? Instead of sending it to the police, when you press emergency button on the vehicle, then immediately that vehicle has to broadcast all the information to the vehicles which are nearby, and thereby there is a highest possibility of protecting the the case, right? So that kind of communication is also very important. So here I wanted to demonstrate those kind of scenarios where when you press emergency button, immediately that information has to be broadcasted to the nearby vehicles. So when you have nearby vehicles, so they can be identified by a Bluetooth, or they can be, for example, say when you switch on your Bluetooth, you can easily identify what are the devices around it, right? So when you switch on your Wi-Fi, you can easily identify what are the devices, what are the networks available nearby. So based on that, we can easily understand that there are some vehicles nearby, and we can easily broadcast the data. So when we broadcast the data, so all the vehicles will be notified, and when they get notified, immediately it pushes the notification to the driver saying that some vehicle which is crossing you is an emergency. Then immediately you will be tracking that vehicle instead of police coming to the vehicle. So that kind of communication is also very important in the smart cities. So let's do that. So one is like the intervehicular communication. So let us talk about intervehicular communication. So in the intervehicular communication, let's talk about two scenarios. One scenario is like vehicle talking to another vehicle. Okay, it can be related to help, or it can be related to emergency. Say my diesel was getting over, then immediately I need an assistance to the nearby vehicles. So if you directly ask someone to help you, so they don't help, right? So they'll think that something is going to happen there. But if the vehicle is sent, say if the diesel is going to over and there is no nearby petrol bunks, then immediately this vehicle wants to broadcast that information directly to the other vehicles which are coming up. So if there is any vehicle who wants to help, then obviously they can help it out, right? So those kind of scenarios, vehicle talking to another vehicle. So here the vehicles are talking to another vehicle, wherein so they are seeking for help. So when you talk about help, that help can be, you know, say if the wheel was punctured, say there is no equipment in order to replace your wheel, okay, so then you need some help. So if that help is broadcasted to the other vehicles who are you know, going through that route, then obviously, you know, you may get help, right? So those kind of communication are very important when you talk about inter-vehicular communication. So vehicle talking to another vehicle. So and second scenario is like, you know, an emergency scenario, or you can say, okay, an emergency scenario. This emergency scenario can be like, you know, an ambulance talking to another non-ambulance vehicle, okay. So generally they will be hitting siren, right? So when they hit siren, then obviously we will be understanding that there is emergency vehicle which is behind us, and we will be giving some space, right? So here, when you put an emergency scenario, when the emergency vehicle send a message to the inter-vehicular, then obviously it will alert the user. If the user is not alerted, then obviously no, you know, the what do you call it? We'll have this say what you can say, so if the driver is not alerted, say, then immediately, so a voice assistant will be popped out from the smart vehicle, and that voice assistant can give you a voice you know, acknowledgement to the driver. So if the driver is not bothered about it, then immediately it will send a data to the you know, the control network of the car, and you know, the car can be stopped immediately, or you know, the lights can be dimmed, or you can say the vibrator will be on. So you can alert driver in all possible ways, right? So you can vibrate the steering, so if there is an emergency vehicle walking up, you know, or coming through the road, so you can do any kind of mechanism there. So which is like in an emergency scenario where emergency vehicle is talking to a vehicle which is non-emergency vehicle there, and also emergency vehicle can talk to a traffic signal post directly. So that is also where I would like to demonstrate it now. So let's do that. Emergency scenario wherein emergency vehicle, emergency case, okay, let me take this scenario also. This is inter-vehicular communication, and also let me talk about vehicle to traffic signal communication. So wherein a vehicle wants to communicate with traffic signal, say I wanted to go straight, or I wanted to go left, or I wanted to go right. So this kind of data, say this kind of data is being collected from the traffic signal from different vehicles. So based on the you know, based on the left, based on the right, based on the straight, you know, the traffic signal will able to understand that how many number of vehicles are there. It can able to identify the traffic density, and based on the traffic density it can schedule the time even, right? Say in one route, if you have more number of vehicles, then obviously you have to put long timer so that all the vehicles will go, right? So the timer of the traffic signal can even be monitored by the number of vehicles that is sending data to traffic signal. So data coming up, you know, the data coming up from the vehicles will be helping us to, you know, is helping us to identify how much timer we have to keep, and also in which way we have to give a green signal and all. So those kind of data analysis can be done on the traffic signal post here. So I wanted to demonstrate these two scenarios. So let me jump into the first scenario and let me do that. So have you understood my agenda? So my agenda is very simple. I wanted to create inter-vehicular communication, and also I wanted to create a vehicle to traffic signal post communication. So if you have this kind of communications everywhere, so then obviously it will be helping us to understand how many number of vehicles are there, and what is the traffic density and all. Okay. So to do that, let me use Raspberry Pi. Okay, so I have plugged in my Raspberry Pi from morning. So let me open my Raspberry Pi. I'm having one Raspberry Pi with me right away. So let me log in into that. So let me use magnifier. Password is Raspberry. Okay, yep, from morning onwards it is switched on, so you can able to see the previous output, right? So let me clear the screen. Okay, let me come back to the smart city folder. Let me create a folder called traffic junctions, or you can say traffic pole. Okay, traffic pole. Okay, so we are in the traffic pole folder. So here let me create two scenarios, as I said. One is inter-vehicular communication. So let me do inter-vehicular communication first, and then slowly we'll jump into the vehicle to traffic post conversion. Okay. So I wanted to use a protocol in order to demonstrate how a vehicle communicates with another vehicle. Okay, so there are two ways of communication here. If a vehicle wants to communicate with another vehicle, sometimes people use like MQTT protocol. If you have MQTT protocol, so obviously you need a broker. So you will be putting broker in between them. So one vehicle will send data to broker. So broker will be sending the data to another vehicle there. So you can use MQTT protocol, or you can use simple socket communication also. Through WebSockets also we can able to transfer the data. So as we discussed about MQTT protocol from the last 4 days, I just wanted to use another communication protocol in order to demonstrate. Okay, you can use MQTT protocol here, but for you to understand, I am using one more communication protocol which is called socket. So I will show you the communication between one vehicle to another vehicle through socket, or else you can also integrate over MQTT. Okay, so let me explain this topic by using socket communication. So what is socket communication? Socket communication is nothing but a communication is being transferred in terms of sockets, where in socket will be implemented on TCP/IP communication protocol. So in particular, socket is nothing but it follows server client model. So one fellow will act as server. So when you look at ShareIt is the best example of socket communication. Okay, ShareIt was banned across India, but we can take it as an example. ShareIt, what happens is, so two mobiles will be very nearer, right? So if you want to use ShareIt application, if you are aware of it, so if you want to use ShareIt application, two mobile phones should be very nearer. So say if one phone is in Hyderabad, if the second phone is in Delhi, you cannot communicate through ShareIt, right? So ShareIt generally phones has to be very nearer. So thereby we can use ShareIt, right? So in order to share files. So here also, when you talk about inter-vehicular communication, vehicles will be nearer. So if the one vehicle is in Hyderabad, if the second vehicle is in Guntur, so there is no need of building a communication between inter-vehicles, right? So you cannot have any kind of requirement, right? If the vehicles are too far away. Say if the vehicle is just meters away, say 1 meter away or 2 meters away, okay, or 100 centimeters away, or 30 centimeters away. So if you have that kind of scenario, we can use ShareIt kind of thing. Okay, so if you want to communicate with traffic police, say traffic vehicle will be at one place, and traffic vehicle generally will be they will be on this, right? So they will be traveling here and there. So then obviously we have to use something like MQTT communication protocol in between the vehicle, in between our vehicle and traffic vehicle there. But here, when the vehicles are very nearer, we can use something like ShareIt. So in ShareIt, if you see, one fellow will act as sender, the other fellow will act as receiver. So the fellow who acts as sender, so say if he wants to send a request, say from my vehicle wants to send a request to the neighbor vehicle. So the neighbor vehicle has to receive data, right? So here, so there comes the concept of socket communication. Socket communication is all about server and client. Okay, you will have one server and you will have one client. Okay, server is nothing but a person who wants to receive data. So let me put it in this way. So let me open my Google Colab. So I wanted to implement socket communication between the vehicles. Okay, socket communication between the vehicles. I can use MQTT, but I just wanted to explain the socket communication also. So socket communication, socket generally works on sender and receiver. Okay, you will have communication is all about exchanging data, right? So which is nothing but sender and receiver. Sender and receiver. Who is sender? Who wants to send information, right? Say vehicle 1 wants to send a request. Say wants to send a request. Send a request. And vehicle 2 and vehicle 3 are nearby. Vehicle 2 and vehicle 3 are nearby. So what vehicle 1 has to do? Vehicle 1 has to broadcast all this data. Say broadcast all this request to vehicle 2 and vehicle 3. Okay. So every vehicle will have some ID. Okay. Will have a random ID. Okay, so it is nothing but you can say a network name, or you can say a vehicle name. For example, so when you switch on your Bluetooth, so immediately it will identify all the Bluetooth devices nearby, right? So every Bluetooth device will have a Bluetooth device name, right? So something like that. So an identity, so which is given to the vehicle there. Say in the smart vehicle scenario, every vehicle will have a unique ID. So based on that ID, we have to communicate. Okay. So that ID will be open, public to everyone. So anyone can send data through that public ID. So that is how the infrastructure has to be created. So vehicle 2 and vehicle 3. So vehicle 2, say vehicle 2 ID is say ABCD, and vehicle 3 ID is XYZ. Say okay. So we have vehicle 2 ID and vehicle 3 ID. If you know ID, we can able to send data. Okay, it doesn't, there is no need of accepting the request, or there is no need of disconnecting the request and all. You can easily send data. Okay, but generally in Bluetooth you have to pair up, right? So here also you will have a little pair up, so that is not so important, but you have to pair up with the vehicle 2 in order to send data, so that we can do very easily. Okay, so vehicle 2 ID is ABCD, vehicle 3 ID is XYZU. Okay, so here the person who is receiving data are like, so they are called servers. Okay, so the person who is receiving data are called as servers, so they will act as servers, and the person who is sending data will act as clients. Okay, one client, one car can send data to multiple servers. Okay, one client can send data to multiple servers. It indirectly means that one client can broadcast all the data to all the servers which are nearby. So you can do that kind of communication in between the vehicle to vehicle. So one sender, so one client. So receivers can be many. Okay, say my tire was punctured, but I am not having any equipment. Okay, so I will broadcast this data to the nearby all servers. Okay, so my vehicle will act as client, so all the other vehicles which are nearby will act as servers. So that will broadcast all the data which is nearby. So then immediately all the vehicles will be getting some data. So if the data is fine for them, then they will be doing some help. Okay, so they will be sending some acknowledgement, and the vehicle will get stopped nearby and help will be seeked out. Okay, so that is fine. So let us understand how to create this kind of communication. Okay, so let us have vehicle 1, vehicle 2 and vehicle 3. So vehicle 1 wants to send a request, vehicle 2, vehicle 3 are nearby vehicles. So I wanted to demonstrate this scenario wherein vehicle 1 has to send a request. So sender, who is sender? Sender is nothing but called client. So in socket communication you will have server client model. In MQTT protocol you will have publisher subscriber model. So pub and sub model is MQTT protocol, and server client is socket communication. So there is a lot of difference between them, right? So in MQTT protocol, publisher and subscriber both are clients, but here this way the sender is client and receiver is nothing but server. Okay, so let me talk about this. So here, so in between server, so server has to send data through socket to client, and the client also can send data through socket to server. So in between them there will be a socket. Okay, so the socket is nothing but in between the overhead tank and the cork. Say I am having cork in the wash basin, so in between the cork and overhead tank there is a water pipe, so that is nothing but socket. So socket is nothing but an end point from where communication is getting transferred and from where the communication is received. Okay, so which is like in our homes we used to have power sockets, right? So what is the meaning of power socket? So power socket is nothing but a place from where power is collected. So in the similar way, so when you talk about socket is nothing but a connectivity in between the two devices or in between the two applications, or you can say. Okay, so here it is inter-vehicular communication, so it is in between two vehicles. So socket will connect both server and client. Okay, so let us talk about this programmatically. So let me do all this. So let me jump back to the Raspberry Pi. Okay, so here what I will do is I will create 3 folders. Okay, I will create 3 folders. So let me create 3 folders. mkdir space vehicle 1. So let me say V1, mkdir space V2, mkdir space V3. So there are three vehicles here, V1, V2 and V3. Okay. So when you type ls, you can able to see V1, V2 and V3. So let me, since I'm having only one Raspberry Pi, I will demonstrate entire application in only one Raspberry Pi. Okay. So I don't have 2-3 Raspberry Pis here. So that is why what I'll do is, that is why I have created 3 folders here. So if you have 3 Raspberry Pis, it means 3 vehicles. Okay. So one Raspberry Pi is nothing but one vehicle. For demonstration, what I'm assuming here, all 3 vehicles are connected on the single Raspberry Pi. Okay. But in the real time scenario, you'll have different computing boards, right? So you'll have one computing board on one Raspberry Pi. You will have the another computing board on the other device. So you'll have different types of boards here. Okay. So let me open one vehicle, cd space V1. So it is in V1. So in the similar way, let me open one more prompt. Okay. So which is like, here also I'll open V2. So ls, so cd space IoT smart city. I'll open V2 here, cd space V2. Okay, I guess it is in traffic pool. Okay, cd traffic pool V2. I'll open cd space V2. Okay, and also let me open one more terminal. So each terminal represents one vehicle here. cd space smart city, cd space traffic pool, cd space V3. Okay, so we have V3, we have V2. Okay, so let me clear. Okay, so we have V2 and also we have V1. So let me clear. So we are having 3 prompts. One is at V1, second one is on V2, third is on V3. So which is on vehicle 1, vehicle 2 and vehicle 3 for us to understand. So here vehicle 1 wants to send a request. Okay, so if vehicle 1 wants to send a request, as I said, vehicle 1 is nothing but client. So vehicle 2 and vehicle 3 are nothing but servers. Okay, so let me jump back to V2. Let me create some programs here. Okay, sudo space nano space v2 s.py. Okay, v2s.py. So and also let me create on V3 sudo space nano space v3s.py. Okay, so we have v3s.py here and also we have v2s.py. So here what is this v2 and v3? So as I said in the Google Colab, you can able to see here, as I said in the Google Colab, v2 and v3 are nothing but receivers, right? So vehicle 2 and vehicle 3 are receiving the request from vehicle 1. So receivers are nothing but servers. That is why I have given S. So V2S is nothing but vehicle 2 server. V3S is nothing but vehicle 3 server. Okay, so you can easily understand. But what is V1? V1 is nothing but client, isn't it? So sender is nothing but client. So let us create sudo space nano space v1 c.py. What is C here? C is nothing but client. So I have created 3 files, v1 c.py which is client, v2s.py which is also server, and v3s.py which is a server. So v2 and v3 are servers because they are reading data from client. Okay, so let me write programs here. So we have to import. So let me talk about socket communication. So I am using socket communication here. So I wanted to import a library. To implement socket communication is socket. So this is socket library. Socket library has to be imported. So after importing socket library, what we have to do is we have to create a socket instance to get connected. Okay, to get connected with socket. So let us create a socket or instance which is nothing but s equal to socket.socket. So here the first socket is method, this is called module, and the socket is called function. Okay, we have the parentheses open and close, right? So that is called a function which gets connected with socket. Okay, s equal to socket.socket. So after creating a socket instance, we have to configure the socket with its ID. Okay, so let us have ID. Okay, so let us have ID open to everyone. Let us have ID as so 127.0.0.1. okay, and also let us have the port number as 12345. So random number, say a common ID or unique ID, you can say unique ID or whatever, 12345. okay, 12345. Say 12345 is changed, will be changing from vehicle to vehicle. Okay, so vehicle 3 is having 12345. Vehicle 2 will have this different ID. Okay, so which is unique ID. So unique ID will be generated there. So let us configure that. Let us configure the socket with those details. Okay, so yes dot bind up. So we have to pass ID. Okay, so let us create some variables. Okay, so let us create some variables. ID equal to 127.0.0.1 and port number equal to 12345. So this two, the ID will be same, but port number will be changed from vehicle to vehicle. Okay, so s dot bind of ID comma port. So s dot bind of ID comma port. So ID is nothing but string value, so which is like 127.0.0.1, and port is nothing but an integer value, which is 12345. So 12345 is a port of V3. Okay, this is a port of V3. Okay, and then configured will be socket. The socket will be configured with these details. Immediately it starts listening. To the broadcast receivers. Okay, it starts listening to the broadcast receivers. Say s dot listen of 5. Okay, where it can activate up to where it can receive up to 5 broadcast receivers. Okay, it start listening. So s dot listen of 5. It start listening to the 5 broadcast receivers. Okay, at one instant. So let us have an infinite loop, because always this has to receive, right? So always this has to receive. Always in the sense it's an infinite loop. Always it has to receive data. So we have to write an infinite loop here, while true colon, and then let us accept the request coming from the first vehicle, which is like c comma addr equal to s dot accept. So this is a syntax. So here vehicle 1 will send a request. So vehicle 1 will send request. Then vehicle 3 has to accept it. Okay, so let us print got connection from vehicle or got request from vehicle. Okay, and let us see what is that request. Okay, let us see what is that request. If you want to see that request, we have to receive data. So let us say t equal to, or some variable equal to c dot recv. What is recv? Receive. So receive of 1024. So it can receive up to 1024 bytes of data. Sorry, it can receive up to 1024 bytes of data. So what is the data? That is nothing but request coming from vehicle 1. Okay, so first request has to be accepted by the vehicle 3, and then it will be understanding from which vehicle it got. So you can write the address also, from which ID you got that, and t equals c dot rec of 1024. So the data will be received and print of t. So print of t. So that data, that request will be printed there. Say if he is interested to help, he can write k equal to input of, so do you want to help? Okay, do you want to help? Say if k is yes, or k double equal to y, whatever, or k double equal to capital Y, whatever. If k is yes, I wanted to help, then c dot send of yes, I wanted to help you from k1 k3. Okay, from vehicle 3. So I wanted to help. Okay, else we have to send c dot send of, no sorry, okay, so I'm just sending the acknowledgements. If I wanted to help, I will say yes, so then immediately yes I wanted to help, so that data will be sent to the vehicle 1. So here who is c? C is nothing but vehicle 1. Okay, c is nothing but vehicle 1. Okay, so c dot send is nothing but sending data to client. So client here it is v1. So that's all about the program v3s. So we are done with v3s, and then the vehicle will stop and the driver will be helping the the driver of vehicle 1. So all things will happen in that way, right? Okay, so here as per the program, so it is sending a data to the vehicle 3, and the vehicle 3 is accepting here. If he wants to accept, he can say yes. So say that when you look at smart vehicles, you will have an assistant, right? So when you're driving, the vehicle says that you got a request from so and so vehicle, so this is a command, so this is a request coming from them. So if you wanted to help them, say yes, then immediately the driver will say yes, I wanted to help, then immediately an acknowledgement will be taken by the assistant, and that assistant will be sending the data to the other vehicle assistant there. So it means that all the smart vehicles will have smart assistants, something like Alexa deployed, so something like Google Assistant deployed on the vehicle. So all the vehicles will have smart vehicles, right? So in the next coming days you will see smart vehicles. So when you have smart vehicles, it keeps sending data to the other vehicle through assistants. So driver no need to send any data, so the driver has to give voice request to the assistant, and the assistant will be doing its job there for the driver. So those kind of assistants will be there. Okay, we are assuming that there is an assistant there, so I just wanted to say yes to the assistant, then the assistant will be sending the data in the back end. So I just wanted to show that code. Okay, so this is v3s. So let me exit from this, Control X, Y, enter. Okay, so we have written program for v3, fine. So let me write program for v2 also. Okay, so here also we have to write same program as v3. So let me write the same logic. So here v2, right? So v2 server. So let us import the socket as fast as we could. Okay, and then we have to write our ID. So our ID is 127.0.0.1, as we are on the same vehicle. Okay, so as of now on the same Raspberry Pi. So let's have port number different. Okay, so let us put 1 2 3 4 6 instead of 5. Okay, this should be unique. Okay, this should be unique enough. Okay, and then so let's create a socket object s equal to socket.socket. We have to create a socket object, and then s dot bind of id comma port. So we have to bind, and then we have to activate the server, which is s dot listen of 5. So it can receive up to 5 broadcast receivers. And then one infinite loop, so always it has to receive data. And then c comma addr equal to s dot accept, same as your v3. Okay, so when any client sends a request, so it will accept it. Okay, print got connection from so and so, say addr. Okay, so here we have to receive the client request c dot recv of 1024, and we have to print the data, then only we can able to see what it is requesting us. So print of t, and here say if you want to help, say you have to read the data, k equal to input of, enter your response, whatever. Okay, say if your is yes, or k double equal to small y, or whatever, k double equal to capital Y, then we have to send yes I am ready to help, yes I am. Okay, yes I am ready to help, else sorry c dot sender sorry whatever. Okay, so this is a program which we wrote in v3s also, but here what is the change? The changed thing is like the port number, right? So instead of 1 2 3 4 5, So I have kept 1 2 3 4 6, which is a unique value. So let us exit from this. So the V3 and program and V2 program are same, because both are servers, broadcast servers, okay, which receives the broadcast messages there. Okay, so let us focus on V1C. Okay, so here let us have the mechanisms like, so this is client program. Okay, so as of now let us write as I'm doing on the same Raspberry Pi. So if it is on different Raspberry Pi, we can scan, but here as we are doing it on the same Raspberry Pi, we have to list it out. So let me list it out. Let me import socket library first. Okay, so let me list it out. So what are the ports there? What are the IDs? So ID say 1 2 3 4 5 and 1 2 3 4 6. So these are the IDs of two vehicles, right? So generally in the real time we will be scanning it. So we will be scanning it in the real time scenario, but as of now, so I'm just writing in the list. So 1 2 3 4 5 comma 1 2 3 4 6. So here what I'll do is I'll try to broadcast the data to this IDs. Okay, so let me create a definition here, function definition, def space broadcast request. Okay, broadcast request of T. Okay, so let us create an object as equal to socket.socket, and then okay, let me create a socket object here as equal to socket.socket. So which is nothing but creating a socket object. So creating a socket object. Okay, so and then here let us connect. Okay, so s dot connect out say 127.0.0.1 comma T. Okay, s dot connect. S dot connect. So let us have the data request. Okay, s dot send of I need a technical kit, or I need a toolkit, say to fix my wheel. Okay, say my request is I need a toolkit to fix my wheel. Okay, so say T equal to s dot recv of 1024. Okay, print of T if T dot starts with sorry or yes, or you can say sorry, whatever. If T dot starts with sorry, then pass. Okay, or we'll say we'll return 0. Okay, we'll return 0, we'll return false, else we'll return true. Okay, we'll return true. So let's have some kind of logic. Okay, so return true if it is not sorry, return false if it is sorry, whatever. So I have created a function with return true and false. So what I'll do is for I in ID. What is ID here? ID is nothing but list. Okay, so for in ID, so what is ID here? 1 2 3 4 5 comma 1 2 3 4 6. So now what will happen is it will broadcast all the data. So let us broadcast that, broadcast underscore request of I. Okay, underscore request of I. So if it is true, I will exit. Okay, I will break from this for loop. Okay, else say if it is not true, then it will continue, right? So fine. Okay, else say print no request coming up. So no vehicle is accepting your request. Okay, no vehicle is accepting request. Okay, for us to understand. So for in ID, so 12345 12346, so it will, what will happen, so it will broadcast request to 12345 first, and then it will send all this data, and then to 12346. Okay, so your data will be communicated. Fine. So we are done with vehicle1c.py. Okay, so we are done with vehicle 1, and also we are done with the 2 programs. So I'll share these programs onto the Google Colab. You can also test it out. Okay, so let me run this program sudo python space v2s.py. Okay, and also let me run this program sudo python v3. Before I go for, let me once again check the program. Okay, so what is the program? Okay, acha, so let me write simple sorry. Okay, let me run this program sudo python v3s.py. okay, so let me also check this. Okay, let me have simple sorry. Okay, fine. Okay, let me also check this program whether I have wrote sorry or not. Okay, so I think it's cool. So I think it's good. So let me run this program v1c.py. Okay, 1 second. So there is some argument. Okay, so here it has to be written in tuple. Okay, so let me put it in tuple. Okay, so let me run this program. So v1c.py, it will broadcast the data to v2c and also to v3c. Okay, yes, on v3 I have got a request. So I need a toolkit to fix my wheel. So that is a request coming from vehicle 1. Okay, so do you want to help? So let me say y. Okay, what did he saying? Y is not defined now. Oh, this is Python 2, right? So in Python 2 we have to make some changes. So v3s.py. So let me, in Python 2 there is a problem with input. Okay, so let me change it to raw_input, and also let me change it to strf. Okay, so this is only one change, but in Python 3 input will work directly. Okay, so let me save this. In Python 2 there is raw_input, so let me change this also. Okay, otherwise I'll get error again. Sudo nano v2s.py. So this is for Python 2. Okay, but in Python 3 I don't see you'll get error. So this is due to the version change. Okay, raw_input and strf. So this has to be typecasted. Okay, nice. So let's clear the screens. v3 is ready, v2 is also ready. So let me check at v1. So v1 is also ready. So let me run v3.py first. Okay, so you can run any program first. Okay, sudo python v3s.py. So let me run this program. Yes, this program is running here. So let me run this program sudo python v2s.py. So this program is also running perfectly. So let me run this sudo python v1c.py. So immediately what will happen, it will broadcast the request to vehicle 2 and vehicle 3. Okay, you can see here. So I got a request from vehicle. I need a toolkit to fix my wheel. So this is a message coming from vehicle 1. So do you want to help? Let me say yes. Okay, so then immediately it will send a request to vehicle 1. Okay, yes, I wanted to help. So this is a request coming from vehicle 1. Okay, so which means that vehicle 1 has sent a request to vehicle 3 and vehicle 2, and vehicle 3 has replied it saying that yes, I wanted to help immediately. The vehicle 1 has got it, like as I wanted to help. Okay, so let me show you one more time. So let me run this program. So it will send a request to vehicle 3, say vehicle 3 is not interested, okay, so let's say N, I don't want to help, then immediately, so that will send data to, what is this? It's already connected. So it is saying sorry, right? So when it is saying sorry, then immediately there is a problem in the program. So let me look into the program. Okay, so what we have to do is we have to disconnect. Okay, so the problem is we have not disconnected here. So yes dot close. So this close will disconnect from the server. Okay, disconnect from vehicle 1, because Bluetooth also, if one it is connected to one Bluetooth modem. Okay, so if your car Bluetooth is connected to your mobile Bluetooth, so the other Bluetooth device it cannot connect, right? So we have to disconnect it first in order to connect it again. So we have to close it. Okay, so here also we have what we have to write is s dot close, then only it will get disconnected. So otherwise you cannot connect with another vehicle. So we have to disconnect it. So Control X Y. So let me clear the screen. Sudo python v1c.py. So it will send a request to vehicle 3. Okay. And do you want to help? No, I'm not interested. Say no. So I'll get sorry on my vehicle 1 dashboard. Okay. What is this? Again there is an error. Sorry. V1c on bad file descriptor. Okay, let me see what is the error there. Okay, so let me put this way. Let us create a socket object instantaneously instead of creating it for only one time. So I have kept the statement inside so that it will create every time as we have disconnected. Okay, let me check it now. Sudo clear. Let me put clear. Sudo python v1c.py. So this will send a request to v3. I'll say no. Okay, so then immediately it will send a request. Sorry, I have received sorry from vehicle 3. Okay, fine. So it will send a request to vehicle 2. So vehicle 2 is getting a request like I need a toolkit to fix my wheel. So I say yes, I'll help. Then immediately on vehicle 1 I should see as I'm ready to help. Okay, so then the vehicle 2 will be stopping at vehicle 1 and the help will be seeked out. So that is fine. If the vehicle 2 is also not available to help, say, so there is also scenario like both vehicles are not helping vehicle 1. So let us execute that. Okay, so let us check that. So vehicle 1 is sending broadcasting request to vehicle 3. So vehicle 3 is not interested, say no. Then no, then it will send a request to vehicle 2. So here also say no. Then on vehicle 1 it says that no vehicle is accepting your request. So no vehicle is accepting your request. So this is a message coming up from the assistant saying that no vehicle is accepting your request. So generally we are typing yes and no, right? But in the real time scenario your assistant will be saying it. Okay, so the driver has to say yes or no. Okay, if the driver is not replying, say a driver is not interested to reply, then the assistant itself will understand that and it will send a request back to the vehicle. Okay, because all the assistants are friendly, right? Though the driver is not supporting, say driver is not bothering about the message coming from the different vehicle, then what assistant will do is assistant will wait for 1 minute or 2 minutes and then it immediately sends a message saying that sorry, I'm not interested to help. Okay, so which means that the default message is coming from the assistant saying that the driver is not interested to support you, so you can do it. Okay, so you can send the broadcast message to the other vehicles. So which means that one vehicle is connecting with another vehicle through socket communication. So in the socket communication, if you see, so there are IDs given like 12345 and 12346. I will share these programs in the Google Colab, so you can test it out at your end. So if you get any errors or if you get any doubts, you can also call me up. Okay, so that is what I wanted to say. So any doubts in this part? So vehicle 1 is sending a request to vehicle 2 and vehicle 3. So if vehicle 3 is seeking a help, say if vehicle 3 wants to help vehicle 1, so then it will say yes, I will help. Then immediately they both will be communicating there, yes, I am ready to help and all, and so the help is seeked out. So any doubts here? Do you have any doubts? Please let me know. So any doubts? Can I go for next part? So no questions asked. So I'm going for next part. So here, so I have demonstrated vehicle to vehicle communication using socket communication, and also you can replace with MQTT protocol also. So when you replace with MQTT protocol, that is also fine. But here I wanted to demonstrate, I wanted to explain the concept of socket communication. That is why I have used socket communication here, or you can simply use MQTT communication also. Okay. So let me stop the programs. Clear. So all three vehicles, okay. So let me stop all the programs. Okay. So now let's talk about vehicle to traffic post. Okay. So let us talk about vehicle to traffic post. So let us use MQTT communication here. Okay. Since I have explained through socket communication the intervehicular communication, let me use MQTT communication here. Okay. So let us have one more terminal. Okay. Or yes, let us have one more terminal. Okay. So here let us create a traffic pole. Okay. So ls city space IoT smart city. So city space traffic pole. So let us, so here v1 v2 v3, let us create a folder for traffic. Okay. Pole, let's say mkdir space t. So ls, so you can able to see t. Okay. So cd space t. Okay. So we are having t, which is traffic pole. We are having v3, which is vehicle 3. Okay. And we are having v2, which is vehicle 2, and we are having vehicle 1. So here I wanted to demonstrate the communication between the vehicles and traffic pole. So in order to create a smart traffic signal. So here, so as we discussed about vehicle intervehicular communication between V1, V2 and V3, so using socket communication, now I wanted to use MQTT communication between V1, V2, V3 and traffic pole. Okay. So through MQTT protocol. So if you are aware of MQTT protocol, so in the day 2, day 3 we have discussed about it, right? So what is MQTT protocol, how to create a publisher. So yesterday also in AWS IoT core also we have used MQTT protocol only, right? So here let us use the MQTT protocol in between the vehicle 1, vehicle 2, vehicle 3 and also traffic pole. Okay. So here if you look at the scenario of vehicles and traffic pole, so we have to understand who is publisher, who is subscriber. So if you look at vehicles, vehicles will keep publishing the data in which direction they want to go. So the traffic pole is a subscriber. It will collect all the data from all the vehicles. Okay. Let's say. So let's say here, let us write program. So before that, let us check whether library is installed or not. So you can check it, right? Pip install. So sudo pip install paho-mqtt. So it will check whether the library is installed or not. Yes, requirement is already satisfied. So which means that library is installed. Okay, so let us implement the MQTT protocol between them, between vehicle 1, vehicle 2, vehicle 3 and traffic pole. Okay, so let me create files. Okay, sudo nano. So vehicle 1 pub, which is publisher .py. Okay, in the similar way, let us create v2 pub.py. So all are publishers, only traffic signal post is a receiver. Okay, subscriber. So let us have v3. So let us have sudo nano v3 pub.py. Okay, so v1, v2, v3 are publishers. Okay, so other after some time we'll write subscriber. Okay, so let us write v1. Okay, let us write v1 program. So here this is v1 is wants to send data to traffic signal. in which direction this vehicle wants to move. Okay, then immediately say this vehicle wants to move towards, say, straight. Okay, towards right. So let us do that. So import paho.mqdt.client as MQTT, import space time. Okay, paho.mqtt.client is a built-in package that is available in Raspberry Pi for implementing MQTT protocol. So after importing these modules, what we have to do, we have to create a client object, right? So client equal to, I remember the syntax as mqtt.client. Okay, client equal to mqtt.client. Okay, so let me say client.connect. So we need to connect with broker, right? So what is a broker? Broker.hivemq.com. So you can have the so in the real-time scenario you will have the traffic police broker. Okay, so which is like, a server which holds all the requests. So as of now, so let us take a public broker, broker.hivemq.com, and port number is 1883. Port number is 1883. Client.connect of broker.hivemq.com, 1883 is the port number. So let's say print connected to traffic police broker. Okay, so which is nothing but a server which is holding all the requests. Okay, so let us publish the data. Say client dot publish stuff. So based on the GPS you can able to identify which traffic which place you are from, right? So we are at, so you can easily identify that. As of now there is no GPS location, GPS receiver connected with Raspberry Pi, but when you have GPS receiver you can obviously identify the latitude and longitude, and you can easily identify all this, right, location and all. So as of now let us say I am at, let us say I wanted to send data on a specific location. Okay, say say Kukatpalli. Okay, traffic / Kukatpalli. So which means nothing but one place in Hyderabad. So there is a traffic pole at Kukatpalli junction. So I wanted to transfer the data to that traffic pole, comma vehicle number. So what is a vehicle number? Say let us have, say AP or TS Telangana state, say 03 whatever 6447. Okay, let us have this. Okay, dollar hyphen straight. I wanted to move straight. Okay, so here we have received so what we are doing here, we are publishing the data on traffic / Kukatpalli. So on this topic I wanted to send data which is like the vehicle number and also in which direction I wanted to move. Okay, so this is a program. So what we did here, we have imported the package, we have imported the time library. So this program is managed by assistant in the car. Okay, so in your vehicle there will be an assistant if it is a smart vehicle. So we are assuming that everything is smart. Okay, so your vehicle is smart and the traffic police is smart. So thereby we are assuming all this and we are building these applications. So client equal to, so here we are creating a client object and that will be connected with the traffic pole broker, and then saying that so this is connected to traffic pole, or you can say pole. Okay, and then we are identifying the location. So based on when you have GPS location, when you have the smart vehicles, you can easily identify the GPS location. So from the GPS location you can identify the place, so where your car is at. So randomly I am writing Kukatpalli. So it means that the data will be transferred to this topic on the broker. So saying that this is a vehicle ID followed by in which direction I wanted to go. Okay, hyphen straight. So let me write a similar program on vehicle 2 also. Okay, on vehicle 2 also. Here also let me have something like vehicle 3, so sorry, vehicle 2 wants to move straight. Okay, wants to move straight. Say import space paho.mqtt.client as MQTT, import space time. So we have to create a client object, client equal to mqtt.C client, and let us have the connection with the traffic pole broker. So client dot connect up broker.hivemq.com 1883. So client dot publish. So let me have print statement here. Okay, print of broker connected. So client dot publish of. So let me send my vehicle is also at Kukatpalli. Say traffic/Kukatpalli, comma, say some different number. Okay, TS 1234 space straight. Okay, so I am sending my vehicle number followed by straight. Okay, client dot publish. Okay, so let me check what. Yes, so let me check vehicle 3. Okay, so vehicle 2 is also done. So vehicle 3. So let me talk about vehicle 3. Vehicle 3 wants to move in right direction. Okay, wants to move in right direction. Say it has to lean towards right. Say then import paho.mqdt.client as mqdt. So we have to create a client object, client equal to mqdt.C client, and client dot connect of broker. So broker.hivemq.com 1883. 1883 is a port number. So let us print connected to pole. Okay, whatever. And so we wanted to publish client dot publish tab. So what we have to do? We have to publish on traffic slash Kukatpalli. But this time this vehicle wants to move towards right side. Okay, so let us have the vehicle number TS 03 space say 1247 whatever hyphen right. So here, so we have this data. Okay, so let me write the same data on my notes for programming. Okay, TS 031247 hyphen right. Okay, so let me exit from this program. Control X Y enter. So I have exited from V3 program. So let me exit from V1 program or V2 program also. Control X Y enter. So V2 program is also done. I'll share all this program. Don't worry about the programs, but understand the concept. If you understand the concept, so if you have the program, you can easily implement it, right? So V1 is also I'm exiting. So let me jump back to pole. Okay, so this is traffic pole. So here we have to design a receiver. So let us create a receiver, sudo space nano space receiver. Say, so let us have t sub.py, which is subscriber. So let us implement. So here we have to receive data from publishers. Okay, so let me have this subscriber. Let me receive all the data. Okay, let me import the module paho.mqdt.client as mqdt. Let us import time library, and let us create a client object, client equal to mqdt.C client, and let us connect with broker, which is traffic pole server, broker.hivemq.com and 1883. Okay, so client.subscribe. So it has to subscribe for its own topic, right? So what is the topic here? Traffic/Kukatpalli. So that is the topic, isn't it? And here we have to create a list of vehicles. Okay, so we have to create a list of vehicles. Say list of vehicles equal to square bracket open and close. So which is nothing but list of vehicles. Okay, and also let us have the count variable. Say if this is a T junction. Okay, straight, left and right. So let us have three variables here. Straight count equal to 0, left count equal to 0, right count equal to 0. Okay, initially let us have the count value to zeros. Okay, and let me have the notification function here. Okay, so let me print. So let me have three argument passed to it. So user client user data message. Okay, so let me print what it is received. Okay, and then I'll write the logic. So print of msg.payload. So let us see what it is printing there. So client dot on underscore message. So you are aware of it, right? Notification. And client dot loop underscore forever. So this is a program. So this is the simple program, but we have to add some logics because we have to give some signal, right? So let us read the data first. So whether it is receiving properly or not. Control X, Y, enter. So let me run the program. Okay, it has to connect with broker. So did we write any logic like it has to connect with broker? Okay. So let me run vehicle 1. Okay. So let me run the vehicle 1 program. Sudo python v1.pub.py. Okay. Oh shit. Okay. So there is some spelling mistake. That is fine. Let me check that. So this C should be capital. I have pressed capital C only. But okay. So let me clear the shell. Sudo python v1pub.py. So connected to broker. So it has published the data. Let me see whether it is received or not. Yes, it has received. TES036447 want to go straight. So the message was printed on traffic pole, right? So it has to go straight. So let me do that. Let me understand how many vehicles are there to go straight. How many vehicles are there at the traffic pole? So let me understand that. So let me put clear sudo space nano space tsub.py. So let me have the count variable to 0. Okay. So let me have the syntax in such a way that let me hold it in t variable. So let me have t equal to msg.payload. So let us have count plus equal to 1. So whenever it gets a message, it means that there is one vehicle there. So or I'll increment the value of t if I add it to the vehicles list. Okay. So okay. So let me remove this. Okay. So let me let me split. So print of t dot split of hyphen. So I have given hyphen in the data. So for extracting the logic, print of t dot split of hyphen. So let me run the program. Okay. Now program is running. Let me publish the data from the traffic pole, from the vehicle 1. So it has sent the data. So let me see whether it is received or not. It has received. So we have TS036447 and straight is splitted. So direction is splitted and the vehicle number is also splitted. So let me store it in the vehicles list. Okay. So let me store it on the vehicles list. So we have list underscore vehicles equal to square bracket open close, right? So let me put it this way. So let me have so let me store it in t variable again. Let me put this way, t equal to t dot split of, and let me have list underscore vehicles dot append of t of 0. So I wanted to append into the t of 0. Okay. So list underscore vehicles. So list underscore vehicles dot append of t of 0. So the vehicle number will be appended to the list there, and let me append. Okay, let me append only if it is not a member of list underscore vehicles. Okay, so if the sometimes the vehicle will be sending multiple requests. So if I want to go straight, say if I send 10 times straight, so it doesn't mean that there are 10 vehicles there, right? So there is only one vehicle there. So that is why what we have to do is we have to avoid duplicate requests. So there will be duplicate requests coming up from different vehicles. Say if you ask me to press a horn for only one time, then what drivers will do? Drivers will continuously press horn. Okay, so that duplicate request will come, right? So that is why what we have to do is we have to compare. We have to check whether this request has been received or not. So then what I will do is I will write simple if loop. If say let me store the id equal to t of 0. Okay, and the direction d equal to t of 1. Okay, so let me put this way, if id in list underscore vehicles, if it is already there, so this will return true. If it is not there, it will return false. Okay, so here what I'll do is, if ID is not in list underscore vehicles, then only we have to append. Okay, so we have to append when it is not available in. Okay, we have to append only when it is not available in, and also we have to then only what we have to do, we have to compare. Okay, if it is not available, then if d double equal to straight, then what we have to do, we have to increment the value of what, straight underscore count. So we have to increment straight underscore count plus equal to 1, and also we have to check whether it is right. So if it is right, we have to make a right count. Okay, so we have to increment right underscore count plus equal to 1. If it is left, d equal to left, then obviously we have to check, okay, left count plus equal to 1. Okay, so straight, right and left, so we have stored that in the we have incremented by 1, so because we are getting a request from vehicles. And also let us make the vehicle count to incremented by 1. Okay, so let us have the count variable. So we have a count variable here, so count plus equal to 1. So thereby we will get the density. Okay, this is called density in one lane. Like this you have to duplicate it, right? So you have to duplicate it 3 lanes. So we have to calculate the density of one lane, say straight lane. So in one, say if it is a T junction, so in one lane you have to calculate the density. In the second lane also you have to calculate the similar way, you have to calculate the density, and you will have 3 densities. And you can compare, okay, in which lane the density is high, and based on that you have to make your the light there. So let us have the we got the density here. So when we got the density, we can simply operate it. Okay, so now say let me write a simple logic here. Okay, so let me have if id not in, okay, count plus equal to 1. Okay, count plus equal to 1. Let us print all this. Okay, so print count, and also let's say the density of count, and also let us have print straight. So who wanted to go straight underscore count. Okay, print straight, and then say left, who wanted to go left. Okay, left underscore count, and print say right, who wanted to go right, so right underscore count. Okay, so I just wanted to print the information here so that you can understand. Okay, so the density is calculated. When the density is calculated, you can simply switch the lights, right? So the density is calculated here. I just wanted to show you how to calculate the density based on the request coming from different vehicles. So let me exit this program. I'll share this program. Don't worry about the program. So let me type the execute the program sub.py. Okay, so let me run the first program. Okay, so let me run the first vehicle program. So sudo space python space v1 pub.py. Okay, connected, so it has sent the data. So now let us go for traffic poll. Sudo python t sub.py. Okay, so let me run it once again. So is the data communicated? No. So let me see what is happening there. So let me have print statements. Okay, otherwise I cannot understand whether data is received or not. So let us have the print statements also. list underscore vehicles. So let us print this data also. So all these print statements will help us for debugging. Okay, if there is no output, then we can understand whether it is receiving or not. So let me run the first program. So it has sent the data. Let me see whether data is received. Yes, we have received the data. So the vehicle number is also stored in the list. Okay, so straight, so we are getting straight also, but something is happening in the program. Let me check the program. Straight, so T of 1. So let me print the value of D also. Okay, so let me print the value of D, so that we will be understanding whether it is printing the same or not. Okay, so let me run the program. Connected, so it has to print. Okay, so here it is printing straight, straight. Okay, fine. So let me once again check t sub.py once again. Let me see why it is not incrementing there. So D is straight. Okay, count plus equal to 1. So but there is print statement here. So this ID, what is this ID? T of 0. It's not in list underscore vehicles. Then we are asking to append, but here it is not comparing D with straight. D with straight, what is the error? D equal to straight, straight. Is the spelling correct? I'm just checking the spelling. Okay, it is correct. Why it is not entering? Why it is not comparing here? If D, what is D straight? So if it is equal, it has to print all this. So it is not printing here. So let me check. Straight. Elif D equal to right, and also elif D equal to left. So there is some error. Let me debug it. So everything is correct according to my knowledge, but there is some mistake in the program. So density discounting print straight, left and right. So count plus equal to 1, left, straight underscore count plus equal to 1, right, left. So everything is correct. Sudo python t sub.py. So let me run the program. So it has to receive the data. It has received straight. Straight, straight. But why it is not entering into the loop? So it is we are getting the output till this, but here it is not comparing. If D double equal to straight is spelling correct, which is written there. S capital. Okay, let me do this way. D double equal to straight. Say if D of 1 let me run the program. It has to execute. Okay, say vehicle 1 straight. So it is getting straight, but it is not comparing there. Why it is not comparing there? If ID is not available, it is appending there. If T of 1 is double equal to straight, so it is also printing that. It is also printing straight, straight. Okay, let me run the second program. Let me see what is happening there. Let me run the second program. Sudo python p2pub.py. So broker connected, then this fellow has to receive data. Okay, so let me run the third program, sudo python v3 pub.py. So it is also connected. So we have got the list 1 2 3 4 1 2 4 7. So those are the numbers, right? So all the data is getting communicated, but it is not counting the vehicle count. Okay, let me check finally. Oh, there is a mistake. Okay, everything is correct. Subscribe, notification, if ID. What is ID? ID is nothing but T of 0. If ID is not in list underscore vehicle, so there is some mistake here. If ID in list underscore vehicles, then it will become true. So let me use not true is false, not false is true. List underscore vehicles and D. So let me remove this. Okay, so let me remove this. So let me run the program for a while. Sudo python tsub.py. So like this it has to communicate, but there is small logic mistake which is written somewhere, but I can debug it. Communicated to pole right. So we are getting a right. RIGHT. Okay, let me print the length of the string. So I guess some space is coming in between. So let me print length of D also. Okay, so let us understand. So what is length of D? Because sometimes space is an invisible character, right? So we cannot see it directly. So there is a mistake. v3 pub.py 325. Okay. Okay, let me do one thing. Let me pass this data to one more function, def space analyze of t colon. Let me have if t double equal to straight. Let me increment the value straight underscore count plus equal to 1. Elif t double equal to right. Let me put right underscore count plus equal to 1. Elif t double equal to left colon left underscore count plus equal to 1. So we have elif if straight left. Okay, so let us have this global variables. Okay, so let us define them as global straight underscore count, right underscore count, and left underscore count. So these are the global variables. Okay, so let me define them as global variables and let me print, and also let me have count plus equal to 1. So let me take count variable also. So global in the sense global variable scope. Okay, so as these are global variables which are defined above the function. So let us print the values here. So density comma count, and also let us print the straight, say how many vehicles want to move straight. So straight underscore count, and how many vehicles want to move right, say right underscore count, and how many vehicles want to move left underscore count. Okay, so let me call this function from the notification function analyze of t. Okay, so let me pass this. So after appending let me pass like this, if id not in list underscore vehicles. Let me append and let me write logic here. Okay, so let me delete all this as we have printed above in the function. So I'm just deleting all these blocks. So here I'll call the function. Okay, I'll call the function analyze of D. Okay, so let me check now analyze of D. So that will go to this function. So in this function it will be compared. So T will be compared. Okay, fine. So let me call this program. Let me execute this program. Sudo space python space t sub.py. So let me execute the program of publisher. So let us send request from vehicle 3. So we can able to see, yes, we got it. Density is 1, straight is 0, right is 1, left is 0. So let me run the program from V2, vehicle 2. So if vehicle 2 is sending data on the traffic police junction, density is 2. So there are 2 vehicles. So what are the vehicle numbers here? So you can able to see what are the vehicles which are there available at traffic pole. Okay, so say TS031247, TS1234 are the vehicles which are available at traffic pole. Okay, and what is the density here? So 2 and 1 and 1. Okay, so this 8 is nothing but the number of letters in this. Okay, so I can delete that. So for just debugging I have enabled it. So here we can able to get the density at one pole. Density is 2, so it means there are 2 vehicles here. So let me run the program of vehicle 1. So when I run this program, so again it sends the data to the traffic pole. So at traffic pole, if you see, you will have 3 vehicles right away. So because we have got request from 3 vehicles here. So density colon 3. So based on the density, based on the traffic density at each pole, you can easily identify where the density is high, and you can automate the signal accordingly, right? So based on the density. So by using this MQTT protocol, we got the density, and also we got say if density is high at one pole, then we got how many vehicles want to move straight, how many vehicles want to move right, how many vehicles want to move left. Okay, and also we got the the vehicle numbers also. So this will help us to identify if any vehicle is theft. So if there is an emergency, then we can process all the data onto the traffic pole, and we can easily identify where the where the vehicle was. If there is any thefted vehicle available, then obviously we can able to identify it. So because the traffic pole is holding all the data which is coming from different vehicles there, and also if there is an emergency vehicle in between them, so we can also send the data, and also we can able to identify it very easily. Okay, so as of now you can see it here. So all the status is coming up on the traffic pole, so using MQTT protocol. So this is how you need to implement. I'll share these programs in the Google Colab. You can also test it at your end. Okay, so if you have any queries, you can ask me here, or you can ask me on WhatsApp also. So that's all I wanted to demonstrate. So I wanted to demonstrate intervehicular communication. So that is more important in smart traffic signal post, and also you need to understand how the vehicles will be communicating data from vehicle to traffic pole. So like this, you have to identify the density. Say nowadays what traffic police is doing. So there are 2 types of timers, right? So one, if based on the timer, generally irrespective of the density, so traffic police will automate the traffic signal in such a way that they'll keep timer, right? So for every 120 seconds or for every 60 seconds your timer will be on. So that will be in round robin scheduling. So one by one, pole by pole, it keeps changing the light. So which is like by using automated timer. But automated timer generally, so though the traffic is not available, but timer will go, right? So you have to wait until timer goes to 0. So though the traffic is not available also. But here when you look at IoT, when you look at smart traffic pole post, so this the smart traffic pole is able to collect the data from the vehicles. So it is calculating the dynamic density. So it is identifying the number of vehicles, and also it is identifying which vehicle is here. So and also you can ask the assistant whether the driver is drunken or not, or you can ask the assistant whether the driver is having license or not. So all the vehicles will be able to push the data also to the traffic police, wherein so all the vehicles will be secured enough, so you can easily implement all the traffic policies on the assistants with the vehicles are all connected to each other. Okay, so this kind of intelligence can be drafted on the traffic pole very easily. So when you keep receiving the data from the assistants of smart vehicles, okay, so everywhere you see you will have an assistant. So that assistant will be monitoring all the policies which are written on the device. So because the driver should, the driver don't want to send data, right? So the driver don't want to send whether he is drunken or not. But the smart assistant, which is connected with a sensory device, will able to drag the data from the driver. So that data will be pushed to the the traffic pole immediately. So if the person is drunken, so the police will be charging accordingly, because they know so the assistant will will read the details of the driver, and also it will post all the details to the police directly. So thereby some protective policies can be written in deriving the smart intelligence on the devices there. So any queries? So that's all. So thank you for joining me afternoon. So today we had all long sessions, right? Morning session was very long and afternoon session was very long. So the topics are designed in such a way that you have to understand how to implement all this on your devices. Okay, I will share the programs. Don't worry about the programs. You can test it out on your Raspberry Pis or on your devices. Okay, so you can implement this kind of framework. So you can propose this kind of framework to the to the AICT in order to get your research projects also. Say if you want to write a proposal on smart traffic police on traffic pole, so then obviously you can have all this kind of frameworks designed on your proposal, and you can write a project to the so these days AICT is giving a lot of funds, right? So you can also draft a proposal in such a way that there should be some intelligence on the smart traffic pole, so thereby you will be getting funds and you can start working on your project. Right, thank you all. I will meet you tomorrow at 11. So tomorrow is the last day. So we'll have some more topics on smart city. So like video analytics. So I'll be talking about video analytics tomorrow, and also I'll be talking about a topic like smart street lights, I guess. So there's a topic called smart street lights which is left out. So I'll be talking about smart street lights tomorrow morning, and video analytics in the tomorrow afternoon session. Right, thank you all. Thanks for joining me. Have a nice day. I'll share all these codes and presentations to your Google Drives shortly. Thank you all.